This is the first look video of the ME1110 Digital Modulation (OFDM) techniques. Before showing you the ME1110 courseware, let's understand what modulation is. Modulation literally meant change. A process by which information is exchanged between individuals through a common system of symbols, signs, or behavior. Modulation is often used in the communication systems. One real-life example is in radio broadcasting. And it is also commonly used in the TVs, cell phones, and Wi-Fi technology. But why do we need modulation? The need for modulation is well explained with the stone and paper analogy. We know that it is impossible to throw a piece of paper a distance of 5 to 10 meters due to the light weight of the paper. However, if we wrap the piece of paper around a rock, we can throw it further than it can originally travel. Here, we can compare the lightweight paper to the message or data signal in the communication system. Similarly, a low-frequency message signal cannot travel across a longer distance without a carrier, which is the high-frequency carrier signal. By embedding the lower frequency signal within the high-frequency carrier signal, that is, a rock in our analogy, we can send the message over longer distances. This process is called modulation. Targeting at second or third year undergraduates, the ME1110 aims to help students in understanding the modulation process using digital signal processing techniques. Introducing ME1110 Hardware Kit. The ME1110 hardware uses a digital processing technique to implement a standard IQ bandpass modulator system with a 10 MHz carrier. Using an FPGA as its core enables flexibility in generating the various digitally modulated bandpass signals. This hardware kit can produce various types of standard analog and digital modulation waveforms, such as sine wave, AM, FM, BASK, FSK, BPSK, QPSK, 8PSK, 16QAM, 64QAM, and the newly added Ofdm. Now, let's take a closer look at the hardware kit. One feature of the board that we want to highlight is that it contains two RF outputs. This allows the RF output to be connected to an oscilloscope for spectrum analysis and demodulation, and to a spectrum analyzer for observing the real-time spectrum at the same time. In addition to the dual RF outputs, the ME1110 board has several analog and digital outputs. For instance, the user can also observe the baseband IQ signals, the baseband digital data, data clock, symbol clock, and so forth to understand how a digital transmitter operates. There are 3 push buttons on the board. For instance, push button 1 allows students to select from one of the 13 modes available, and the LED display will show the selected mode. Next, push button 2 provides students the flexibility in selecting the data from an external source. The 2 ports available on the ME1110 board are the external data input and the clock BNC output. These ports allow students to inject an external serial data from the system, for example, through a function generator. Lastly, push button 3 allows the user to generate the baseband data manually. The user could inject baseband serial data into the board instead of using the internal pseudo-random bit generator. Lab overview of the ME1110. This is a typical setup for the ME1110. The ME1110 board is connected to an oscilloscope. With this setup, students can observe how baseband data is transformed into IQ signals, which are then modulated into a 10 MHz carrier. Finally, the modulated RF signal is then digitized by the oscilloscope and transferred to the VSA software for RF spectrum analysis and demodulation analysis. The previous section shows the typical setup and the flow of the lab exercises. Lab 1 teaches students how to use and operate the ME1110 digital modulation kit. As mentioned earlier, the ME1110 can generate various digitally modulated signals as shown here. Divided into 7 distinctive labs, students will get to study the various digitally modulated signals using an oscilloscope to examine the modulation process from baseband data to modulated RF signals. Using the VSA software and compatible oscilloscope, students can perform RF spectrum analysis, such as RF bandwidth and power measurements, and demodulation analysis, such as IQ constellation and EVM measurements. Lastly, the newly added Lab 7 teaches students to measure and verify the Ofdm signal, as well as its demodulation techniques. Ofdm is commonly used for many of the latest wide bandwidth and high data rate wireless systems, including Wi-Fi and cellular telecommunications, for example, LTE, 4G and 5G. To simplify the learning process, the ME1110 board is designed to generate an 8-carrier Ofdm signal with a total baud rate of 1000 kilobits per second. Using Keysight VSA software and oscilloscope, students can measure and verify the modulation process of Ofdm, measure the bandwidth and power of the modulated RF signal, and perform demodulation process and analysis. Please visit our website for more information about ME1110. You can also view how a lab is being carried out from the labs on video at our webpage. And you can also download the ME1110 datasheet at our webpage.